Here we come to DSE Physics 215 structure question 3. So here we have a pendulum, a acrobat, trying to swing from A to C. So here's what he has done. So he would grab a string of length 8 meters. So he swing from A to B in a pendulum motion. And at point B, he released the string, so he continued the motion along a projectile path. Okay, so we can separate this motion into two sections. First of all, this is the pendulum part. In which we can apply the principle of conservation of energy. And for the second part of the motion, he has released the string, so he is under gravity. So this is the projectile part. So we can make use of the projectile motion in order to solve for this motion. So firstly, we want to find what is the speed at B. Okay, I would call it VB. So VA is 0 originally at rest. Okay, so when the acrobat swing from here to here, actually he is going down. So when he is going down, PE would be converted to KE. And I would like to know what is the distance he has dropped. So we have to consider this triangle. Okay, and let me draw it neatly. So we are considering this triangle. The acrobat is making. Okay, so one thing we are sure about that is that the string remains 8 meters. Now I am interested to know how far did the acrobat drop to go from point A to point B. Okay, so simple mathematics, this side is 8 cosine 30. This is the height the acrobat has been dropped by swinging from A to B. Okay, so we would like to find the speed of the acrobat at B by using conservation of energy. At A, acrobat has PE, and PE loss would be equals to KE gain during the swing from A to B. So PE loss is given by mgh. KE gain is half mvb squared. M is cancelled out, so it doesn't matter what is the mass of the acrobat. G is 9.81. The loss in height is 8 cosine 30 degrees. Solving this equation, VB is 11.659 meters per second. So the acrobat is now swinging at 11.659. So once he releases the string, he will become a projectile at this angle, okay, at under this speed, 11.659 meter per second. So what I'm interested to know is that, so what is the angle? Okay, what is the angle here? This angle, if you try to look at the geometry, this will be 30 degrees because this angle is 30 degrees. The string is making an angle of 30 degrees with the vertical, and because the acrobat is flying perpendicular to the string, so it would be making an angle of 30 degrees with the horizontal. So we know that this angle is 30 degrees. Once we know this angle is 30 degrees, then very good, because we can resolve the speed, the velocity of the acrobat into VB cosine 30 and VB sine 30. We resolve VB into a horizontal component and vertical component. So, part B, it is told that it takes 1.25 seconds for the acrobat to reach C after releasing the rope at B. That means, if we consider the time, we take point B at start, and here t would be equals to 1.25. So it takes 1.25 seconds to go from B to C. And by considering its horizontal motion, find the horizontal separation between B and C. By considering horizontal motion, we know that the horizontal speed is VB cosine 30. The time taken is also known. So now we want to calculate for the x. X is equals to the horizontal displacement within this 1.25 seconds. So it will be equals to the horizontal speed times the time. So it will be equals to 11.659 cosine 30 times time, 1.25. So it will be 12.62 meter. So the point B and point C are separate 12.62 meter away. So part 2, we want to calculate the vertical distance of C below B. I want to know in this 1.25 seconds, how much did the acrobat drop? In other words, we want to calculate the vertical displacement within this 1.25 seconds. So consider the vertical motion, which originally at first the acrobat is going upwards with a velocity VB sine 30 degree. And after 1.25 seconds, where will be the acrobat? So we use the equations of motion. Sy equals uyt plus half ayt squared. So let's put it in numbers. Uy is the initial velocity of the acrobat, which is 11.659 times sine 30 degree. Time is 1.25 seconds. Half. Under gravity, gravitational constant is 9.81. Time 1.25 square. So this will give us 14 It should be negative 9.81. So it will be negative 0.377 meter. So that means when the acrobat swing from B to C, it has gone down for negative 0.377 meter, the vertical distance between B and C. Before reaching the lower platform, is there any change to the acrobat's mechanical energy among the points A, B, and C? Total mechanical energy is conserved throughout all the process. Why? First of all, we know that in the first section, why does mechanical energy conserve? Because the tension of the string always acts perpendicular to the speed. When the force acts perpendicular to motion, there is no work done. So the acrobat would not gain or lose any energy, mechanical energy in total. It would just convert from one form to another form. It would just be converted from PE to KE. But the total amount is the same. This is first section. Second section, the acrobat is acts on under gravitational force, okay, mg. So gravitational force would not cause any mechanical work done to the acrobat because it is already taken into account by considering PE and KE. So the total amount of mechanical energy, PE plus KE, remains the same. So throughout all the process from A to B to C, the mechanical energy would not change.